Hello dear friends, before starting today's video, I would like to take the concurrence from each one of you, the quality of my video as well as audio, is it perfect or not? If it is perfect, just write perfect over the chat box and then we'll move ahead with the second class of the control system, and which is nothing but the basics of the control system. Tell me, if the quality of audio and video, if it is perfect, just write perfect over the chat box. Perfect, okay. Anyways, let me recall what we were studying in the last class. The last class was the first class of the control system, where I was giving a brief idea about the control system. How much hour we are going to spend together is still so many doubts I am getting over the live chat. Around 30 hours we are going to spend together. What about the weightage of the control system? Either you are sitting from the gate, electrical, electronics or instrumentation. Somewhere 9 to 12 marks you are getting from the control system. Would you able to get all of the marks just by seeing our crash course? Probably yes. 100% you are getting almost all marks from the control system. Similarly, sir, may I know in how many days the control system would get over? That solely depends the how much time I take day basis. The put together, I can say maybe in 15 to 20 days, probably maybe maximum 20 days the control system would get over. And even I have shown how the control system would get over. That means in how many parts the complete syllabus of the control system has been bifurcated. So the first part which I have shown in the last class was the basics of the control system. Basics of the control system. So anyway, let me see the live chat. Good afternoon to all of you. Good afternoon to all of you. Yes. See, the basics of the control system. First, one thing comes in our mind. The first question comes in our mind. What is the need of the control system, or what the control system does? So we will start the basics of the control system with the first question keeping in our mind, and that is nothing but what the control system does. So keep in mind what the control system does. Control system does. This would be my question, and based on this question, I would start the basics of the control system. So the answer would be everybody should write each and everything clearly, because end of the day, the notes which you guys are going to make, that's gonna be very handy before the gate examination. So it accomplishes, so you can write, it accomplishes or completes the given objective, or for the time being objective with correct strategy, just a minute, correct strategy. Yes. So let me take few number of problems or the few number of practical examples from where you'll understand how the control system accomplishes the given object with the proper strategy. So let me take the two different examples. Let me take the first example. I have taken the first example, example number 1, and as well as example number 2. I have got the two different scenarios, where in first scenario the runner or sprinter is running on the lap of 100 yards, and similarly in second case, or in the second example, let's take runner or sprinter is running on a marathon. If you talk about the lap of the marathon, it would be somewhere 48,000 yard. Now I wanted to ask one thing. The strategy for completing the lap for the first sprinter who is running on the 100 yard, and similarly for the second sprinter who is running for the 4,800 yard, would it be same or would it be different? Would it be same or would it be different? Although if we talk about their objectives, they are more or less same. May I know what their objective is? To complete the lap in shortest period. The objective would remain very same in both of the cases. Either you take the first case, either you take the second case. Yes. Let me copy this out. Yes. But may I know whether both of them would have the same strategies or they would have the different strategies? A person who is running with the lap of 100 yard and the person or the sprinter who is running with the lap of 48,000 yard. Just I wanted to ask from each one of you, both would have the same strategies or they would have the different strategies. See, as far as the first person is concerned, he will not have any strategy. He'll just close his eyes and he'll just run away. That means only speed is the concern for the first person. Whereas in second case, the person not only had to maintain the speed, even he also had to conserve the energy. Because many of the times it has been seen that many of the sprinters and many of the runners, they are not able to complete their marathon at all. They are not able to complete their marathon at all. That means they not only had to maintain the speed, even they have also to conserve the energy. Could you understand what I am saying? So in future, whenever the control system comes in your mind, definitely the need would also come into your mind why the control system itself is being designed. So what the control system does, the control system completes the objective with the correct strategy. You can see very well, although the objective was very same in the first as well as second case, but the strategies are going to be different. In first case, your strategies would only be maintaining the speed, whereas in second case, your strategy would be maintaining the speed, at the same time you also had to conserve the energy. If you are lacking in either of them, you are finished. But in case of 100 yard, that is not a problem at all, because that is very short span of lap, and there your basic concern would be speed. So more or less, with the help of these two examples, you would be able to connect the control system. So far it was a human being, in future it could be a control system, it could be a system. So system would perform your object, it would accomplish your object, yes, but it should have a proper strategy, as we had the two different examples. Could you understand till this point? So obviously, let me go ahead with the next point. Yes, let me take the next example. And here comes blocks. If you are dealing with any type of control system, may I know how the control system would look like in general? Like you have got the control system, so definitely you would have objective, and corresponding to the objective you will have output. For the time being, the input has been allocated to the objective, and corresponding to the objective you will have output. And obviously this is nothing but control system. Yes. But now it has been seen in many of the times in gate examinations, the input as well as the output has been referred by the different name. And I have seen most of the time the student just gets confused. See, objective, instead the objective, they may write input, sometimes they write excitation, sometimes they write reference input. So why don't we list down all possible ways the input can be referred, and similarly all possible ways the output can be referred. Yes, and this thing should be in your mind, because I have seen in many of the papers or many of the situations they have referred the different name for the input as well as the different name for the output. So keep in mind, in general, this side would be called as an input and this side is called as output. Even the input side is also being referred as a reference input. Keep in mind, a reference input, and in behalf of reference input, the output would be controlled output. Even it has been seen, the input side has been written as excitation, and the output side is also referred as a response. Yes. So in future, in any of the problem, if the input is being referred or the reference input is being referred or the excitation is being referred, just understand in this way, they all are the different ways to represent the input which has gone inside the control system. And similarly, some of the time you will be seeing The output has also been referred by the controlled output as well as response. You need not to worry about it. Basically, they are referring your output itself. And in future, whenever I come across the input, I would be using the first alphabet of the reference input and I would be referring it by R of t. R of t. Yes, and similarly, whenever I come across the output of the control system, I would be using the first alphabet of the output, which is controlled output, which is nothing but C of t, C of t. Agreed? And if I require to study the input as well as output in Laplace domain, small r of t, I would be using capital R. Why the small r would change in capital R, we have seen in the last class, so nobody should have any doubt as such. Yes. And similarly, the small ct would be referred as capital C of S if I analyze the output in Laplace domain. And even the system would also be showing the different behaviors at the different moment of time. For the time being, the control system has been referred by small h of t. So in future, if you wanted to get the Laplace of small h of t, I would be using this as h of s. This as h of s. Yes. So what is it? In future, probably in most of the time in control system, you would be dealing with the R of S, C of S and H of S. So whenever I say capital R of S, basically I am referring my reference input in Laplace domain. Whenever I refer capital C of S, I am referring my controlled output in Laplace domain. And whenever I refer capital H of S or T of S alternatively, basically I am referring the transfer function of the system. So here goes my input in Laplace domain, or reference input in Laplace domain. Here comes my controlled output in Laplace domain. And in future the h of s would be referred as transfer function. Yes. So probably till this point nobody should have any doubt. May I know why the reference input is being allocated instead the input C? In most of the control system, you used to give the reference input, like the class has been taken live from my side, the AC is running here. So what I'll do, I'll give a reference input to the AC to somewhere 24 degrees centigrade. Although within the room the temperature is not 24 degrees centigrade, but still the reference input which has been given to the AC is 24 degrees centigrade. That means you wanted to operate the room temperature at 24 degrees centigrade. So what it is reference temperature. But the room temperature may be somewhere 30 degrees centigrade. So what will happen? The room temperature would slightly go down, and it will try to reach towards the 24 degrees centigrade. So may I know what would be the reference temperature as far as the AC as a control system is concerned? I have given the set temperature to my AC to 24 degrees centigrade. So it would be your reference input. It's not the actual input, reference input. Yes. And similarly, what would be the controlled output? The controlled output, let's take if the room temperature is 30 degrees centigrade. So it would start falling and would try to settle somewhere at 24 degrees centigrade. So just I wanted to ask from each one of you, the quality of audio as well as video now got perfect or not? Now got perfect or not? If it is perfect, just write perfect or just give a thumbs up. Just give a thumbs up. Clear, sir? No? Now all good. Okay. So you guys should not have any doubt as such. Dear friend, still if the technical problem pursues, I need to interrupt my video and probably we had to stop the video here itself. But still we'll try once more time. Probably there was some technical issues and because of that Because of that, the video is getting stuck again and again. But probably if that problem happens again, probably I need to interrupt this video at all. Yes, we'll see. I cannot exactly say regarding the internet speed and all. Yes. Similarly, why we call it the input as the excitation? Why we call it the input as excitation? You need to understand in this way. You have got a system. The system would be energized or excited by the input signal or the input, and hence the input is also referred as the excitation. The input is also referred as excitation. So nobody should have any doubt if the input has been referred by three different times. Input, obviously sir, it's the input because it's coming from the input side. Reference input, why? Because I used to give the reference input to the AC sometime in Delhi where the temperature might be at 10 degrees centigrade. They might be watching my videos with the help of heaters. They might have been used a heater within the room. There the temperature set would have been at 24 degrees centigrade, but there the heater is increasing the room temperature, but still the input which was given to the heater was the reference input. Agreed what I am saying? And in corresponding to the reference input, you would be getting a controlled output. Why? So far the room temperature which was somewhere 30 degrees centigrade, now it is getting controlled as per my requirement, which is going towards 24 degrees centigrade. 24 degrees centigrade. Yes. Similarly, the next thing comes excitation. Excitation, why? Because it excites the complete of the system. It excites the complete of the system, and hence it would be called as excitation. And similarly, once the system is excited, the output is usually referred by response. So obviously it would be response. It would be response. So till this point, each and everything must be clear to all of us. If it is clear, just write yes. Just write yes. Now what I am going to do, now I am going to take few number of mechanical control systems and few number of electrical control system. End of the day, you guys would start feeling what the control system stands for and why the control system design is so important, at least for the engineering domain. Engineering domain. Yes. So let me take the first example. Let me take the first example. The first example comes from mechanical control system. Mechanical control system. The first example comes from mechanical control system. Mechanical control system. Now most of the people would understand or would feel, sir, we are from electrical, electronics and instrumentation. Why you are taking the first example from the mechanical control system? See, visualization, the thing in electrical, electronics and instrumentation is not that easy because we are playing with the parameters like voltage and current. That means we are focusing over the control of voltage and current. Whereas the analysis becomes very difficult if we talk about the control of voltage and current, which we cannot visualize virtually. But once if I take few number of physical problems where your brain can visualize the things, probably you would be able to appreciate my concept in the better way. That is why the first control system which I am taking in today's class is going to be mechanical control system. Try to figure it out how the things are working. So the first system which I am going to introduce today is going to be gearbox system. Gearbox system. Gearbox system. Gearbox system. Yes, it's gonna be gearbox system. It's gonna be gearbox system. Agreed? Now, may I know what the gearbox system does? Anyways, most of us would not be familiar with the gearbox system, but it does a huge amount of work. Try to understand what does it do. Let me take a block diagram. Let me take a block diagram of a gearbox system. Let me take a block diagram of a gearbox system. Gearbox system. Let me take a block diagram. Just a minute, I need. Hello. There is some problem in software. Let me switch on and switch off the software. Probably everything would be fine afterwards. Everything would be fine afterwards. So let me know the quality of audio. Now it's perfect. Hello. So tell me the quality of audio, is it perfect or not? Perfect, no? Okay, we'll do one thing. Let me finish this out. So here is gonna be gearbox system. Here it's gonna be gearbox system. Agreed? Now, as far as the gearbox system is concerned, may I know how the gearbox system manages each and everything? See, you will be having the input from the steering side of your control system, and once you steer your steering, what happens? The complete motion or complete translation goes till your wheels, and the wheels gets deflected. Yes, obviously, yes, everybody would agree on that. So what happens once you are tilting your steering, the movement of the complete steering goes till your wheels, and there used to be the deflection of the wheel. May I know the amount of angle of theta which you have taken over the steering, whether the same value goes till your wheels? No. You will see in big trucks they used to take 360 degree, but still the variation over the wheels used to be maybe 10 degree or 20 degree. Anyways, which has been managed by which system? It has been managed by a gearbox system. It has been managed by a gearbox system. What does it mean of it? That means the input has been applied in form of the angle of deflection over the steering, yes, angle of deflection over the steering. And may I know how the output goes? The output goes as angle of deflection over the wheel. May I know it has been managed by what? It has been managed by the gearbox system. So what the gearbox system does? Gearbox system takes theta of s, which is nothing but the tilt over the steering, and which manage each and everything, and thereafter it produces what? The angle deviation over the wheel. Till this point, each and everything must be clear. Yes. Similarly, if I take a second example, again I take an example from a mechanical system. Let me take another example from the mechanical system. Yes. Mechanical system. In mechanical system, let's take the accelerator system. We have taken an example of accelerator system. May I know what would be the input to the accelerator? If you are driving a four-wheeler, definitely input would be the pressure over the accelerator pad. And according to the pressure over the accelerator pad, you would be getting acceleration over the wheel. So may I know, if the complete structure is concerned, you would have a reference input. What does that mean of it? You would be wanting me to at least deflect the wheel maybe towards the left hand side, towards the right hand side, maybe 10 degree or 20 degree. For that, what you have given? You have given a reference input to the gearbox system, and the gearbox system takes its own input, and thereafter it deflects towards the wheel. And similarly, the same concept goes with accelerator system, where the pressure is applied over the accelerator, and thereafter, according to the pressure over the accelerator, what happens? The acceleration takes place over the wheel. How fast the wheels would move. Is that part clear? So till this point, nobody should have any doubt as such. But by taking the two number of systems, at least I could figure out one thing. May I know what it is? As far as a practical system is concerned, would it have only one number of input or maybe one number of input? Similarly, a practical system, would it have only one number of output or it would have a multiple number of output? Obviously, if we talk about a complete automobile system, there are several number of inputs. Like the first input goes in a form of variation or deflection over the steering. The second input goes in a form of pressure over the accelerator. Third input goes in the form of pressure over the brake. Third, fourth might be going into the terms of pressure over the clutches. There are several number of input a automobile system used to contain, and there are several number of output the automobile used to contain. Till this point, nobody should have any doubt as such. What does that mean of it? A practical system would have single input, single output, or would have a multiple input or multiple output. And from here onwards, basically the system would be classified into the two different parts. The first is gonna be CISO system, and the second is gonna be MIMO system. CISO stands for single input, single output, and similarly MIMO stands for multiple input, multiple output. Tell me. So from here onwards, I am bifurcating the systems into the two parts. Yes, the first kind would be CISO, SISO, single input, single output. Like if you talk about the gearbox system, definitely it has got only one input and it has got only one output. And similarly, if you talk about the accelerator system, it has got only one input and one output. Those systems which have got only one input and only one output, they would come under the CISO system. Keep in mind, CISO is nothing but single input, single output system. Yes, till this point each and everything must be clear to all of us. Yes, and similarly, but if we talk about a complete automobile system together, there would be a n number of input and similarly there would be a n number of output. So may I know, would it be classified under the CISO system or would it be classified under MIMO system? Obviously it would go under the MIMO system. Multiple input and multiple output system. Yes, till this point each and everything must be clear to all of us. If you talk about the example of CISO system, the gearbox system or accelerator system exclusively, they could come under the CISO system. But if you talk about the automobile system, the complete automobile system which you will have n number of input as well as the n number of output, definitely would come under the MIMO system. So let me ask one thing, in practical you are going to deal with a MIMO system or CISO system. So theoretically I would be dealing with the CISO system. Obviously sir, I have got a box has got an input, the box have got an output, and most of the time in control system, 99% time we are going to deal with the CISO system. But once you become control designer or control engineer, you had to deal with the MIMO system, and definitely in practical you had to deal with the MIMO system. So in future, whenever I say CISO, one thing should click in your mind, and that is nothing but the single input, single output. And whenever I say MIMO system, by default, one thing should come in your mind, that is nothing but the multiple input, multiple output. But as far as the gate is concerned, see, whatever the syllabus has been designed in GATE, they are just based on theoretical approach, because once you'll go into the MTech, once you'll go into the PhD, once you'll go into the working platform, definitely you would apply each and every theory over the practical viability. Anyways, my basic question do come from the single input, single output system, where the focus would be over the system which has got only one input and which have got only one output. Anyways, let me go into the next slide, and here let me bifurcate the CISO system as well as MIMO system in terms of block. Here you have got a system, control system. If it is CISO system, what will happen? It will have only one input and it would have only one output. Like, let's take the reference input is R of t in time domain, and similarly correspondingly the controlled output is C of t in time domain again, Yes, but once we talk about the MIMO system, multiple input, multiple output system, here you will have m number of inputs, obviously more than one, and similarly you will have the n number of output. What would be the exact value of m and n? That solely depends on the different practical systems. Yes, here it would be like you can take the first reference input R1t, R2t, and similarly you can take this as Rm of t, and similarly output could be like C1t, C2t, and similarly it could be Cn of t. Yes, and it used to be very least used system in practical domain, whereas in practical domain most of the time you will come across this MIMO system. So what I wanted to say, you can see once again what I wanted to say. So basically I wanted to give a little bit glimpse about the control system. So what I did, I took an example of mechanical system. In mechanical system I took the example of gearbox system. In gearbox system what was happening? The input was fed in terms of input to the steering, how much tilt has been given to the steering, but the same value does not go till the wheels. Everything is getting managed by the gearbox system. That happens, and that is happening at output side. That is what is happening at the output side. And similarly, if you talk about the accelerator system, you would be applying certain pressure over the accelerator system, and according to the input or the reference input, there would be acceleration over the four wheels of your car. And that is why it's input, it's output. So what I did, I classified the system into two parts. What are those? SISO system and MIMO system. What does it mean by the SISO? SISO, single input, single output. Yes, single input, single output. Most of the time in GATE, questions are going to come from the SISO system, which will have only and only one input and which will have only and only one output. But the SISO system or the study of the SISO system is the basis to visualize the concept of MIMO system. That is why we confined our study more or less over the SISO system. Here comes my MIMO system, and as you guys can see, all of the practical systems are used to be MIMO system. Then I went into the sort of block diagram, how the SISO system would look like and how the MIMO system would look like. The SISO system would have only and only one input and similarly one output, whereas MIMO system would have multiple number of input and multiple number of output. Yes, till this point each and everything would be clear to all of us. Yes, now let me go ahead with the next concept. Now the control system are going to be bifurcated in the two parts. Yes, I would be bifurcating control system in terms of whether the feedback is present or the feedback is absent. If the feedback is present, that system or the control system would be called as a closed loop control system. And similarly, if the feedback is absent, keep in mind that control system would be called as a open loop control system. Yes, till this point each and everything must be clear to all of us. So let me go ahead and let me bifurcate the control system into the two parts. May I know what are they? The first part is gonna be open loop and second part is gonna be closed loop. So basically again I am bifurcating, I am classifying my control system into two different parts. The first is going to be open loop and secondly the second is going to be closed loop. Each one of us should write each and everything in the great clarity over the notebook, because once we'll move into the problems related to the GATE, you will see the concepts which has been delivered to you guys, which has been written in your copy properly. Probably all of the questions are going to be smashed with the help of your copy itself. That is what I am again and again saying. Keep maintaining your notes. Agree? Now let me take an example of open loop control system as well as closed loop control system, and by taking an example at last I would be comparing which system is more reliable, which system is lesser reliable, and we'll be taking few more number of parameters on basis of which I would be comparing the open loop system as well as closed loop system. Yes, so what I'm going to do over here, so here the control system, the open loop as well as closed loop. So what I'll do at next, I would be taking the two different examples. Anyways, first let me fix my object. let me fix my object. Let me fix my object, or let me fix my objective. My objective is to maintain 1600 degree centigrade at 1600 degree centigrade at maybe in a certain chamber. Maybe in a certain chamber. Yes. So what you will do? Obviously, you had to place a heater within that chamber. Then only the temperature would raise from its room temperature. Maybe if room temperature is somewhere 30 degrees centigrade, because of electrical heater, the electrical heater would produce heat within the chamber, and the temperature within the chamber would increase and would go till 1600 degrees centigrade. But once it goes to the 1600 centigrade, I should have a control system. It should get switched off to supply the power to the heater. And once the temperature goes lower than the 1600 degree centigrade, again it should start pumping the power. So there are two different methods through which the same system could have been designed. They are the two different methods through which the same system could have been designed. Let me know what are they. See, try to understand what I am saying. How we can design them. First, I am taking the concept of closed loop system. May I know how the closed loop system would work? See, what I have done, I have taken a chamber. I have taken a chamber. Here goes my chamber. Sort of this. Here goes my chamber. Yes. In chamber, we have fixed an heater. Yes. Now the heater has been supplied with a single phase. The input to the heater has been supplied with the single phase 50 hertz power supply. Till this point, each and everything must be clear to all of us. Yes. No. What is my basic intention? My basic intention is to keep the temperature within the chamber is 1600 degree centigrade. 1600 degree centigrade. Yes. 1600 degree centigrade. 1600 degree centigrade. Till this point, nobody should have any doubt as such. But this switch should get off when the temperature reaches within this chamber 1600 degree centigrade, and similarly the switch should get on if the temperature within this chamber is lesser than 1600 degree centigrade. So may I know who is going to operate this switch? This switch would be operated using a perfect control system. May I know how the control system would look like? Try to understand in this way. For that I can take a comparator which will compare your reference input, which is nothing but R of t, and similarly the output temperature. For the output temperature measurement, what I have taken a thermocouple, and the output from the thermocouple comes into the comparator. Now just try to understand in this way. The output from the comparator goes to a coil, and just try to understand how this system would work. Yes, how this system would work. Just try to understand how this system would work. Try to understand in this way. May I know when the output from the op-amp would be logic 1 and when it would be logic 0? See, if this is nothing but VFT, when the value of R of t is greater than the value of feedback VFT, the output would be logic 1. And similarly, when it is just reverse, that means if the VFT is greater than R of t, output would be logic 0. Yes. If the output is logic 1, what will happen? There would be flow of current across the coil, and you can see in this way, if VFT, or you can see R of t is greater than the value of VFT. If the value of R of t is greater than the value of V of t, the logic would be logic 1. Logic 1. And if the output has the logic 1, in that case, there would be a flow of current through the coil. And if there is the flow of current through the coil, what will happen? What will happen? There would be a magnetic field across the coil. See, that part we have seen as a part of electromagnetic theory, so we need not to worry about those things. But yes, once the current flows across the coil, the magnetic field would generate across the coil. So what will happen? If the magnetic field got generated across the coil, the switch would get on. Switch would get on. Switch would get on. And as the switch is on, what will happen? The power supply is on to the heater. Power supply is on to the heater. Yes. Power supply is on to the heater. So till this part, each and everything must be clear to all of us. And as this coil or this switch is injected, power supply is injected to the heater, what will happen? Obviously, the temperature within the chamber would increase. And as the temperature within the chamber is increasing, what will happen? The value of Vf is increasing again and again, and you will come across a certain situation where the Vf would become greater than the value of Rt there. Which sequence would offer? The sequence would be the value of Vft is greater than R of t. In that case, you would have a situation where R of t is smaller than the value of V of ft. In that case, the output would be logic 0, and in that case, the coil will not have any flow of current, and as the coil will not have any flow of current, what will happen? The power would become off. Power would become off. And you can see very well, yes, we are able to manage the temperature within the furnace or chamber. We could manage the temperature within the furnace or chamber. So probably till this point, each and everything must be clear to all of us. May I know whether it's a type of closed loop system or whether it's a type of open loop system? I want the input from each one of you. Whether it's a type of closed loop system or whether it's a type of open loop system. I want the input from each one of you. And then we shall move ahead. Whether it's a type of open loop system or whether it's a type of closed loop system. Of open loop system or the closed loop system. I am watching over the live chat. I want the input from each one of you. Each one of you. Closed loop system. Closed loop system. Why it is closed loop system? Why it is closed loop system? Tell me. Why it is closed loop system? Dear friends, I am taking just a break of 2 minutes, not more than 2 minutes. The technical issues we are getting in between for the buffering, no, let me resolve first. Just 2 minutes. So let me do one thing. So there is no other way. I had to interrupt the session here itself because one software OBS which is getting abruptly off again and again. So I would ask from each one of you, we will meet from tomorrow onwards. Probably my audio would be clear to all of us, but still the software is getting hanged in between. So no issue, you can enjoy with the few of the important points which we have studied so far. We shall continue with the same control system from tomorrow onwards. Is that part clear? Thank you very much.